the X that happens to the Y station.
What's happening?
Alright guys, so let's actually focus. The test is tomorrow.
What the hell? Really?
The test is tomorrow.
There we go.
We have a test?
Hey, I would like to review, so
I
can we
agree with
can
that.
we not?
We have a test?
I want to hear this.
Okay, so the sheet, the piece of paper that I gave you, the sheet. There's two pretty identical questions.
Right?
Both involve capacitors and both involve time. So,
Time.
try to answer it.
Both of them?
Brother, what?
Huh?
They're the same question.
No, they're very much not the same question.
No,
What's an ammeter?
Oh, one's immediately, one's a long time.
Oh,
It's two words that are different.
Oh, okay,
words are
Long time after. Bro,
This is not funny.
this is definitely like such.
What are you trying to say?
got my answer.
Stop talking.
Okay, look.
Barcamp, do you mean to stop it?
Already charged up. Stop. So basically, you ignore it.
Where's my eraser?
Because it's being serious.
I don't like the way this is set
Oh,
up.
you're showing work?
What is
What is this?
Oh, I gotta practice showing.
What's that?
So you do.
Is that just to measure the
I don't know.
Yeah.
Now try this one.
Why do we add that if we need
Look at the
that?
time. Look at the time. Yes.
Okay.
What's
Wait,
neat,
something.
it's gonna go straight, it's gonna go both ways.
Okay, I need to use my brain for this one.
Okay, when they're in parallel.
No, he just said it doesn't affect
They're not in parallel.
Oye, David.
capacitance. Is
David.
Just ignore it.
David.
Ah,
Número 1, ¿qué es?
¿cuál? ¿El uno?
Sí.
¿Sabes cómo hacerlo?
Es nada, ¿verdad?
No, sí sirve.
No sirve.
Pues el ni después de que sea mucho tiempo se cierra. Entonces solo va a pasar por 24 voltajes.
Es cero, ¿verdad?
Hey, do not call me short man.
Sería.
Okay, let me explain
I can.
the difference between these two questions.
Yeah, what
explain
am
it
I
in
even
Spanish?
like
You
looking
guys
at?
get-
So,
Please.
on the first one, it says, what is the current indicated by the amp meter, which is just measuring amps? Immediately, and I emphasize the word immediately after the switch is closed, versus the other side, which says a long time after the switch is closed. Okay?
But like, how do you?
So, remember with capacitors, here's the magic decoder ring that you have to understand, is that immediately after it's closed, that is acting like a piece of wire, and the electricity will flow through it. Okay, now, that might literally be a thousandth of a second, okay? But that's why it says it's immediately, not 10 seconds, not 20 seconds, like, boom, that flash right after you close that switch.
Wait, what acts as a wire?
The capacitor.
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 Just
So it goes that way?
Immediately after. Immediately after it turns
Oh,
off.
shit.
Which one goes left to the left and then down to the right and then up?
So, immediately after it's closed, you're just
Oh,
gonna
yeah,
act
he's
like
the nicest
capacitor
person
isn't
ever.
even there.
Went in
You're just
his
gonna
own
act like
table.
that's a piece of wire,
Okay.
okay?
Definitely.
So, assuming that that is acting as a piece of wire, and it's immediately after the switch is closed, you're gonna have two resistors in parallel.
Right.
Yes?
So since 12 is greater than 6, would it not just flow only through the 6?
It has to be like a huge difference.
Like if one is like full.
So, Adam, we actually talked
Like,
about
they
this
have to have
last
like a
time.
wire and then like 12 ohms.
Here's your thought.
Okay?
Gavin?
Yeah, Kevin, can you please meet up for this class?
Kevin, you don't get offered thoughts today.
Okay.
You've offered it now.
Sorry. That one's on me.
Okay? So it would have to be like a vast difference.
Will we have it on the test?
No.
If I get a better grade than that.
Oh my god.
Okay? Like it would be like a wire and a 24 ohm resistor. Okay? So the 6 and the 12 is going to push them through both of them.
I'm wrong.
So,
Bless you.
now, in contrast to that, where it says a long time
You got it.
after the switch is closed, once that capacitor gets charged, what's going to happen?
And then you
Gonna
can't fall
block it
through
off.
it.
It effectively acts as a dam, and it shuts off any electricity flowing through it.
I want to change.
So then all the electricity is going to go out through
12.
the 12. Okay?
And would that 12 now be a series, or would this still be in parallel?
No, it would just be that.
Parallel
All it
is
is just, there's nothing to it. It would just be just a 12 ohm resistor. It would just be literally just a single 12 ohm resistor.
So is the answer C?
So a long
It
time,
literally be
the
burnt.
question, the side that says a long time after that answer is C, which is 2 amps.
Okay, I understand that, Bert.
The one with immediately after the switch is closed is 6 amps.
You see, that's what I
Hey, I got that.
Okay? So that's the magic code to resistors. Is immediately after you treat it as a wire,
I get
a
that.
long time, you act
Is
like
it
it's
on
an
yours?
open, like you've opened the switch.
Immediately after.
Okay?
Because everything's running
Got
through,
that.
so when it's everything's
Okay,
gonna come
Mara,
out and
stop
go
on the
back
camera, please.
to this ammeter.
Holy ball.
But on this side, it's only going halfway. So that amperage is what's gonna come through here.
The diagram of the brightness.
I'm good.
Because it's flowing through here and here still.
Hey, Bird.
So the total current is the current through that.
So it's C?
Yes, it is.
bro.
Because you have to calculate
there's
them in
more.
parallel.
Let's go,
Ah, pues chinga tu
Birkin.
madre.
Estaba tratando de
What
ayudar,
did you say the
güey.
final answer was?
Bird,
Chinga tu madre.
Immediately after.
one resistor.
Oh, wow.
Like,
Okay.
That's a lot more questions, Bird.
Wait, immediately after was what?
Immediately after, right? They're in parallel. So it's
Yeah,
six.
yeah,
But after a long time,
yeah.
basically this shuts off, and it's in series, so then it's 24 divided by just 12.
Yeah,
Just two.
okay. I thought you said D, not E, for immediately.
Yeah.
We have to calculate Q. And then after
Roll it
that,
up, there's 24 volts. That's it. This is
The average potential energy changeable.
Q is C times V.
Yes.
So the change in V is
What's this
one.
guy talking about?
What is this? I would define the.
Where's the battery?
What?
The 24
Oh wait, I'm stupid.
You said we'll turn it.
which side are we supposed to do?
That's okay.
See, this side doesn't have the battery visual. Like, this one's not as obvious as that.
Z to X. Wait, hold on. It says moving from point Z to point X. When it- You add, right? Oh, well, no, it's.
So,
I need my
Yeah,
t-shirt.
fine. 'Cause we're doing
I'm being so for real, bro. I'm being so for real.
Doing, hey, we're reviewing right now.
My bad, that's what we're reviewing.
I would take 1 minus,
No, the electrons
and
would
the
lose.
blue is,
Yes.
Yeah, because it's leaving, it's heading away from the battery. We're heading away from the
that's how I would.
U equals
He's gonna go deaf.
the UCA.
Minus.
Energy capacitance.
Wait a second.
Yeah, I got that. Our explanations are basically,
So don't try to like
but, I mean, your rank is right, so you basically.
Hey, hey Adam, how are you doing number A?
Number A?
Number A.
Or letter A?
A equals D.
Oh,
Okay, so,
5 or 4? What? 4 or 5?
did everybody get one?
Huh?
5A.
We're doing
Oh, I
four.
was doing 4.
Okay, so in the name of time, do the bulb problem.
Which one's that?
Yeah,
Are we serious?
2012,
I did the other.
number 5,
that's
okay?
Right.
In the name of time, do that one.
Did you say 2012?
This, it's this thing at the bottom.
One with the 4 bulbs.
I realized it said 2012 on the top.
Oh.
Because I promise you, a question like that is going to be on the test.
Let's go through this a little bit.
Promise you.
I think so. Yeah.
On part A1, do not make it difficult.
Oh.
I just skipped A and I went to B.
It's UI equals Q delta V.
If my
Oh,
answer were to
yeah.
start with a
That would
3,
make sense.
Do we
If
add
it made sense.
On
doesn't make
part
sense.
A1,
Yeah,
Yeah.
so it's 1.6 is okay.
Oh,
yeah,
let's
yeah,
switch
yeah, I was right.
Wait, Q delta V for one electron, so like 1.6 times 10 to the negative 19.
Do you use
Are we getting
C
Does
for
that not Q?
capacitor?
What is Q?
I don't think we have any coolants.
that is Q, but you have the wrong number.
Yes.
Use
1.6
these for capacitor.
Yeah.
How did you get that?
10 to the negative 19.
Yeah, 1.6.
Oh, wait.
Yeah.
What? The voltage drop over other resistors.
Yeah.
It is the negative 19. My bad.
Right.
I was thinking 16. You're right.
Wait, so what's the answer start with?
Oh my god.
Yeah. I don't even
That's
have.
3.
Yeah, okay, yeah.
I don't
Yeah,
have a
okay,
question.
Is
Is
this
what
you got?
Yeah.
This is what I got.
Use that.
This is what I got.
Got me tweaking.
For AI. Hey. What did you get for AI?
Oh wait, no,
3.8.
wait.
Yeah.
So does that mean do the 3
To the what?
Because it's going towards
The 18? Negative 18? Negative 18?
Wait, don't we have to find the voltage drop?
Yeah.
I used the to the 19 to the negative.
Oh,
Wait,
that's
yeah,
right.
magnitude.
And V equals.
That
would be joules, right?
For
Well, yeah, but
energy?
these are
What's
the
what's new in those?
Because I was just talking about current, you said that would be
So
joules.
this is 1.2 then.
Sorry.
So it'd be V over V equals IR.
I'm so tired of making
2.4 times.
Dude, I am not a thing.
Does it
Thing one,
lose energy?
thing two.
Group
I
leader.
ain't no thing,
That's what I
pal.
want to say.
Group leader.
You're wearing a cape.
That's your guys' group.
Whoa,
Rock chalk.
whoa.
Rock chalk JL.
That's right. You know, she
Oh,
knows
shit.
ball.
Oh, shit, that's ball.
Hey, rock chalk.
Round to
See,
32
Mara's
out.
smart.
That's ball.
Chin.
Round to 32 out.
Hey, I'm gonna cure cancer one day, and you're gonna regret saying
Since
that.
1989, pal.
We've made 3 natties in the past 15 years.
It'd be great.
The same thing.
I'd be out of a
He's
job,
gonna
but it's
cure
okay.
cancer
You know why we have a
at
chin?
KU.
Because our coach
The
sucks.
past 15 years is one tour.
Hey, focus on this.
Our coach is
It's at
suicide.
KU.
I should
Just-
was born now.
So
This is B basketball, not world
Okay, I
basketball.
got 3.2.
Back in mind.
back in mind.
Whoa, yeah, you're pointing next.
Huh?
Whoa, bad. No, you see my phone.
Okay, so if your answer to 5B is wrong, everything is going to be wrong.
What is it?
What do you have as an answer to 5B?
10
ohms.
10 ohms.
How did you do 5A1?
Wait a minute. Do you use voltage or do you use amps? Which one? Hold on, no. I'm figuring this out. I think the answer is it's amp. Wait.
What does it mean through point Y?
Wait.
So you see the point Y?
Yes.
Which direction do you want the electricity to be flowing? When it's
You're
going
a
through that way.
right now. You're even taking this.
It's either going down or it's going up.
Oh, you
Bird.
just, bro, I'm not gonna remember to do that.
Are you asking us
It's
because
I was
How do I
doing
know?
voltage.
Bird.
Okay, so wait, when you use that
You
again?
ask it.
That-
Wait, do we use the
weird
big
minus
Franklin
thing?
method?
Whenever they're in parallel.
Never
Then you
mind.
have to find the specific current going through.
How do I get number 1?
I think it's the duration of the current through.
He said use UI equals Q
It's
W.
going
Okay,
this way.
what is Q? Q is a constant, pal.
What
is
is
Q?
is charged in 12 on
What is it?
5 seconds.
1.6.
Well,
1.6.
24 volts.
We gotta find average.
No,
If my answer to B and D were
Oh, the
similar,
charge of an
Okay,
electron?
basically, it was for.
Is that bad?
If what?
my answers to B and D, like just the numerical value were similar.
What? It is not.
When it asks for current, it's conventional, right?
What's my like?
What did you get?
B And
D.
D. D, I got 10.
Energy.
Good job.
Oh, what is
Hey, Adam,
this?
don't worry, I got
Is
that
the
too.
direction positive?
Oh, that's comforting. Thing 1 and thing 2
Okay, I don't
got
get-
the same
Not
answer.
good.
I don't bring.
No, Shannon said I'm not
Indicate on
thinking
the
two.
diagram the direction.
Wait, what do you mean,
Is it
and
around
What?
150?
A2 is the
What's
right
that?
side.
Did you just say
This thing's on my energy.
right?
Whoa,
By-
what are you-
what
energy.
would you go-
You indicate on the
Who's that,
diagram.
right?
So you?
Gavin, get away from me.
Oh my god, I'm failing this test.
I use
I can't even.
No, you're not, bro. You
How did
got
you
it.
find the voltage?
I didn't realize it
I don't
said
get why
indicate
we
the
bring up
direction. I thought it said
So
say
it's
the
6 volts, V
direction.
equals IR.
Are you good?
So I did
what
2.4 times
equation
the
is that?
resistance of the parallel.
What direction are you guys
2.4
in?
times 2.
Oh,
Oh, it's using time.
Right.
Yeah, so you just find watts and then multiply by time. You find the watts
All
that's
right,
going
Berg's
through.
gonna walk us through it all.
I did V squared over R.
Okay. Mara, please start that up.
You told me not to stop it.
It's been
Yeah,
going.
you find
Oh,
watts because
so
watts
not-
is joules
Yeah.
over seconds.
They've been here.
All right.
Energy not
So,
charged.
on 5A, potential energy change as an electron. Now, this is important. It's an electron.
Yeah.
Okay?
Not proton.
So, let's just start at the beginning. If you're talking conventional current, and this is the positive terminal of the battery, and there's the negative terminal,
Yeah.
which direction would conventional current flow? Clockwise, counterclockwise? Clockwise. Okay? An electron is gonna move counterclockwise, right?
Yeah.
Okay? So unless you're specifically told you're worried about an electron, don't. Assume that it's conventional current. So it says determine the average potential change of the electron as it moves from point Z to X. So it's going to go from here all the way through all of this up to X, right? Which means it's going to undergo that voltage drop of 24. So you know that UI equals Q delta V.
Yes.
So how much voltage drop is there going to be across between X and Z?
All of it.
24.
All of it.
You have to do the.
Okay.
I did.
So it's charged 1.6 times 10 to the negative 19.
David,
Your voltage
He's
is
teaching.
24.
that's my camera.
Okay.
Same, bro. Same.
Luis.
I was telling
Stop.
you he was in the camera.
Okay. So is the electron gaining or losing potential energy as it moves from Z to X?
Decreases.
Decreases. But where is it gaining it?
Battery.
Back
Once it
at
gets
Back
to
from the
the
battery. So it's going to lose that potential energy going through here. It's going to gain it going through the battery. Okay? Cool with that. All right. Now, the equivalent resistance, we said that was 10 ohms.
Yeah.
You have to be able to do that in your sleep without any hesitation.
Yeah.
Which one?
B.
I did that one.
Okay, then that's good.
Good.
You don't have to sleep.
Then calculate the
Resistance.
the magnitude of the current through
So
point
2.4 times.
Y. Okay? So, that answer,
Which one?
go,
Yes.
going through Y should be 1.6 amps.
Can we go through that? Just real quick.
Yeah, go do that real quick.
Okay, you know the equivalent resistance is going to be what?
10.
10. So that means how much current is going to be flowing through the entire thing.
2.4 amps.
So you're going to have 2.4 amps flowing into this point. So you got a 6 ohm resistor and a 3 ohm resistor. Which one's going to carry more current? The 3 ohm or the 6 ohm?
3
ohm.
So what I would do,
Oh, that's right. I remember.
I would take the 2.4 amps, which is how much current is flowing into it, and then do one minus, because it asks for that 3 ohm. You got 3 divided by a total of 9.
Oh, I didn't use those numbers.
And you
Oh,
get
okay.
1.60.
There's more than one way you can do it. This is just what I would do.
I like
Okay,
that.
that's
Right?
not what I did.
Elliot,
don't think I gave you a strategy. Where's the 9 come from?
You had 6.
that's the
Add 'em up.
total of
6 was
the
6.
3 and the 6 ohm resistors in parallel.
Because if it was equal, you split it in half, right? But since the
Yeah.
resistors are different, you have to figure out.
So this is just this constant of proportionality,
Pipe down.
which tells me how much is going to flow through each side.
Okay.
If you wanted to find the 6, you take 6 over 9 and 1 minus that times the 2.4. What? Hold on, let me get it. Okay. Now, when it gets to part 2 on C, where it says indicate on the diagram the direction of the current through Y, it asks for current. Is the current going down or is the current going up? Current's going down. So you would draw something like that. Okay? Current is old school Ben Franklin positive charges.
You know how it's going to be on the test?
Dude,
I'll sit out. Just don't
Just
answer the
beat him
question.
up.
Anything that he's gone over could be on the test. Just assume.
Like, are we using conventional the whole time?
Oh my god.
He just said that.
You, honest to God, not listen to a single word I say.
This is rage.
Well, I was
Whoa,
doing
whoa,
this. Do not
whoa,
listen.
whoa, whoa, whoa.
I was doing this, and I'm also thinking of my senior assessment escape plan.
Okay, on D, where it says calculate the
I
energy
just-
dissipated in the 12 ohm bulb in 5 seconds. There's any number of ways you can do it. You can pivot up, you can use V squared over R, you can use I squared R, I don't care. But remember, watts, once you get watts, that's joules per second.
oh my god.
How much time does it ask for?
5.
5 seconds. So that answer on D should be about 154 joules,
Wait, which
Huh?
one?
They're not,
not
the same.
10.
D.
Well, see, I
Because it's-
actually was
oh,
thinking
so
Coulomb.
Do something that does take.
Yeah, I put
Okay.
mine in coulombs too.
No. Here's your end story. And this is E. This is what, this is the
writer's gonna be.
prize at the end of the day.
Right.
Here should be your ranking on E. Should be 4, 3, 1,
This
2.
one's 19.
What?
What do you have, Adam?
Oh my, we have nothing like
No,
that.
no, it didn't happen. It didn't happen. That
What
didn't
do you
happen.
mean 5?
He has 2, 3, 1, 4. It doesn't matter. It doesn't matter.
How did you get a 5?
So
Can
on
you re-repeat
E,
it?
4, 3, 1, 2.
did you have a 5?
No, he didn't have a 5. Nathan was lying.
My bad. I was playing.
Why does the one with most resistance? How does it?
4, 3, 1, 2.
Wait,
Wait.
So it should go 4, 3, 1, 2. Bulb A is 4, bulb B is 3, bulb C is 1, bulb D is 2. Smash mouth physics.
Oh, I mean, what is
Okay.
going
Okay, I just have
on?
to remember what changes to say the same parallel. In
That was
parallel,
this. I
amperage
said it.
changes,
Okay.
voltage is the same.
Okay, well,
Series,
So,
voltage changes.
On the other side, let me see that sheet. Okay, so on this one, very likely to have a question like this as well. It says rank the magnitude of the potential differences. So remember, potential differences is just a measure of what? Voltage.
I don't know.
So here's the story.
bro.
So on that one, you should have A equaling D, which is greater than B, which is going to equal C.
Oh, I got that.
What?
Okay? So when in doubt, set up a verb chart.
Oh.
Okay? When in doubt, set up a verb chart. On that next question where it says, and you have to justify that, you can see B and C are in parallel, but they split the current. C and D are in series. So that next question, you see it? Only through the, you see it. Where it says, on part B, when resistor B is removed, does current increase, decrease? It's going to decrease. And then that last answer C is increases. So, now, last thing I'm going to give you. This is obviously not a quiz. It says it is. But the answer key is on the back of this. Okay?
You're
So-
the best.
It's not for a grade, literally. Here's the answers on the back. But if I were you all, I would work this and not even glance at the back of this thing until you got completely done. So,
I don't remember.
South people, I know you all have to go. Here we go.
I remember that.
All right, Mara, stop the camera, please.